Hello everyone, this is Dr P Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about T distribution for single mean. So, before going to start T distribution for single mean, so here we have test of hypothesis for small samples. There are three types of tests are there in test of hypothesis for small samples. So first one is T distribution, second one is F distribution, third one is chi-square distribution. So here we have three tests or three distributions are there in test of hypothesis for small samples. So first we will discuss about T distribution. So in T distribution also there are two types of tests or two types of distributions are there. Two types of distributions are there. So first one is T distribution for single mean and second one is T distributions for difference of means. So first we will discuss about T distributions for single mean. So before going to start T distribution for single mean, so first of all once again we have to recapitulate. So what is small sample? So, small sample is nothing but if n is less than 30, so if the sample size n is less than 30, so then we can say that that is small sample. Okay. So, next one is, next we will discuss about T distribution for single proportion. So, now we will discuss about T distribution for single proportion. So, for this, consider a sample of size small n with mean x bar and variance s square is taken from the population having having mean mu and variance. So population variance sigma square. Then the test statistic is given by T equal to x bar minus mu by s by root n. Okay. So this is nothing but our formula. Okay. So here the test statistic, that is nothing but formula, is here T equal to x bar minus mu by s by root n. So before that I will explain you. So what is population and what is sample and so this is population. Population is nothing but a huge amount. So collection of all objects. Collection of all objects is known as population. So what is sample? A part of the population or subset of the population is known as sample. So here remember these points. So population size. Population size is denoted with capital N and the sample size. So that is denoted with small n. And the population mean is denoted with is denoted with mu, and the sample mean, so that is denoted with x bar. Okay. So next, population variance. So population variance is denoted with sigma square and the sample variance is denoted with s square. So next one is population standard deviation is denoted with sigma and sample standard deviation is denoted with s. So remember, so these four along with these four. Okay. So here once again we'll discuss about T distributions for single mean. So consider a sample of size n. This is sample size n and the sample mean is x bar. Sample mean is x bar and sample variance is s square. Sample variance is s square and is taken from the population because sample is nothing but a part of the population. So that is taken from the population having the population mean, that is mu, and population variance, that is sigma square. Then the test statistic, that is nothing but our formula. Okay. So our formula is here T equal to x bar minus mu by s by root n. So this is our formula. So sometimes they will give S value. So sometimes they will not give S value. In that case, here we have formula S square equal to 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square, or 1 by n minus 1 sigma I equal to 1 to n xi minus x bar whole square. So what is the meaning of sigma xi minus x bar whole square? So this is nothing but sum of, so this is sum of squares of, so this is a deviation. So deviation from the means. Deviation from means. Okay, so this meaning is summation I equal to 1 to n xi minus x bar whole square is nothing but sum of squares of deviations from the means. So that is S square. So S square equal to 1 by n minus 1 into summation I equal to 1 to n xi minus x bar whole square. Next. So we can choose the tabulated value T alpha by 2. So here we have to take, so alpha is 5%, then we need to take in T distribution alpha by 2. So that means if alpha is 5% means that is 0.05. So we need to take alpha by 2. So that means 0.025. Okay, so we choose the tabulated value T alpha by 2 at nu equal to n minus 1 degrees of freedom. So this is available in the T distribution table. Okay, so new values are always like this. New values are always like this. So these are all alpha values. So these are all alpha values. So these are all alpha values and these are all new values. Okay, so by using this T distribution table, we can find this tabulated value T alpha by 2. Okay, so we choose the tabulated value T alpha by 2 at nu equal to n minus 1 degrees of freedom. So next one is conclusion. So the conclusion is if mod T less than T alpha by 2, then if mod T is less than T alpha by 2, then accept the null hypothesis. If mod T is greater than T alpha by 2, we reject null hypothesis. So problems. So here we have problems. Our first problem is a random sample of 6 steel beams has a mean of 58,392 psi with standard deviation of 648 psi. PSI means pounds per square inch. Use this information at level of significance 0.05. Test whether the sample came from the population with mean 58,000 psi. So observe the question carefully. A random sample of 6 steel beams. A random sample of 6 steel beams. That means here that is nothing but sample size. Sample of means sample size. So here they have given that n equal to 6. 6 steel beams has the mean of, so continuation sample size along with continuation will, sample mean will come. So that means sample mean. So sample mean is denoted with x bar. So that's why, so here they have given that x bar equal to 58,392. So along with, so here we have sample standard deviation. So sample standard deviation. We know that sample standard deviation is denoted with S. So S is nothing but here 648 psi. So use this information at level of significance 0.05. So how to denote level of significance? We know that it is denoted with alpha. So here alpha equal to 0.05. So now test whether the sample came from the population with mean 58,000. So that means population mean mu equal to, so mu equal to 58,000. Okay. So solution, coming to the solution. So here they have given that n equal to 6, x bar equal to 58,392, s equal to 648, and what about alpha? Alpha equal to 0.05 and mu equal to 58,000. So what we have to find here? So test whether the sample came from the population with mean. Okay, so came from the population with mean 58,000. Okay, so this is our statement. So here in the null hypothesis, I am taking same statement as it is. Okay, so that is, so the sample came from the same population. Here I am taking, so that population is 58,000. Okay, so first, so before going to find this problem, so first we need to follow the 5 steps. What is our first step? First we need to set up the null hypothesis, then alternative hypothesis, so then test statistic alpha, and from this we can find Z alpha, or here in test of hypothesis, t distribution for single mean, no, this one. So that's why here we need to find t alpha by 2, and here we need to write the formula, that is test statistic. So that means here we need to write the formula, that is, so which here these are the values. These values are given in the question. Okay, so these values are suitable for x bar minus mu by s by root n, right? So that's why we need to use this formula. So after that, our fifth step is conclusion. So what is our conclusion here? If mod t is less than t alpha by 2, so then we accept h naught. Okay, so if mod t is greater than t alpha by 2, then we reject h naught. Okay, so this is our procedure. So we have to follow this procedure for this entire small samples. Okay, so how many small samples are there? So we have t-test, f-test, chi-square test. In t-test, we have 2 methods. First one is a t-test for single mean, and t-test for difference of means. So what is the difference with these two? Okay, so t-test for single mean is there also in large samples, and t-test for, test of hypothesis for single mean is there in large samples. T-test for single mean is there in small samples. What is the difference between these two? So here we have to take n is less than 30. So here n is less than 30. Then we can use this formula. So if n is greater than or equal to 30, then we can use test of hypothesis for single mean. Okay, test of hypothesis for single mean we can use. So like the difference of means also. So next, our procedure is, so here, so coming to the problem, so here they have given that n equal to 6, x bar is 58,392, s is 648, and alpha is 0.05, mu is 58,000. Okay, so now we have to solve this problem by using the procedure. So what is our procedure? Step 1, here we need to construct the null hypothesis. So null hypothesis is nothing but we denote with h naught. Okay, so in the question they have given that the sample came from the, so here we need to test what is that, so here we need to test the sample came from the same population with mean 58,000. Okay, so that's why I am taking mu equal to 58,000. Okay, so here the sample came from the same population with mean 58,000. So that's why I am taking this one. So next, alternative hypothesis. So alternative hypothesis is nothing but opposite to the null hypothesis. So that's why in test of hypothesis for small samples, we need to take only not equal to. That means here we need to follow only two-tail test. Okay, so alternative hypothesis, mu not equal to opposite to the null hypothesis. That's why we have to take mu not equal to 58,000. So next, coming to the third step, so that is level of significance. So for level of significance, they have given that alpha value. So here alpha value is 0.05. So now we need to find t alpha by 2 at nu equal to n minus 1 degrees of freedom. Okay, so t alpha by 2, so 0.05 divided by 2 at nu equal to, so what is n value? N value is 6, right? So n value is 6. So that's why here we need to write 6 minus 1 degrees of freedom. So t 0.025 at nu equal to 5 degrees of freedom. Okay, so how to take this value? So we have to take this value from the table. Okay, so we have to take this value from the table. So we have to take from this table, from the t distribution table. Okay, I will show you how to take this value from the table. In the t distribution, this is our t distribution table. So this is our t distribution table. In the t distribution table, so here we have the alpha by 2 value, that is 0.05025 is there. And here, these are all new values and these are all alpha values. So these are all alpha values and these are all new values. So in all, here we have alpha value, that is 0.025. So we have to choose this column along with, we have to find for nu equal to 5, right? So new value is this one. So that's why the total value is 2.571. Sorry. This is for 5. So 2.571. So alpha value is 0.05 and new value is 5. So that's why T alpha by 2 value is 2.571. So we have to take T 0.025 at nu equal to 5 degrees of freedom. So that value is 2.571. So we have taken from the table. So that means this is T alpha by 2 value. So now coming to the last step, fourth step, that is a formula. So here we need to write the formula. Our formula is already we have discussed here. So what is the formula here? So our formula is, so here it is fit to this formula. So the formula is t equal to x bar minus mu by s by root n. So t equal to x bar minus mu by s by root n. So what is x bar value? X bar value is 58,392 minus what is mu value? Mu value is 58,000 and what is s value? S value is 648 and n is 6. Okay. So substitute all these values in the formula. So after simplification we will get t equal to 1.48. So this is our calculated value. But we need mod z, right? Mod t, right? So that's why we need to, if we have a t equal to minus 1.48 also we need to take 1.48. But here we are having only t equal to 1.48. So that's why mod t equal to 1.48. So now last step, coming to the last step, that is conclusion. So here mod t. So what is mod t value? Mod t is 1.48 and t alpha by 2. So already we have taken from the table. Okay, so T alpha by 2 value is 2.571. So this is 2.571. So is 1.48 is greater than 2.571 or less than? So 1.48 is less than 2.571. So that means mod t is less than T alpha by 2. So we know that this is calculated. We have calculated this value. That's why this is calculated value. So calculated value, and this value we have taken from the tables, right? So that's why this is tabulated value. Okay. So here the calculated value is less than tabulated value. So therefore mod t is less than T alpha by 2. So that's why we accept null hypothesis. So mod t is less than T alpha by 2 means we accept null hypothesis. That means we accept our statement. So what is our statement? Our statement is the sample is came from the same population with mean equal to 58,000. With mean equal to 58,000. Okay. So that is correct statement. So the statement is correct statement. So our next problem is a random sample of size 16. From a normal population, the mean of sample is 53 and sum of squares of deviations from the mean is 150. Can the sample is regarded as taken from the population with mean, having mean 56 at 5% level of significance? So this is our question. So in this question, identify the sample size. The sample size n equal to 16. So n equal to 16 means whether it is small sample or large sample. Yes, you see, this is small sample because here n is less than 30. Here n is less than 30. So that's why here this is a small sample. So that's why we can use this is for t distribution for single mean. So from the normal population, the population mean here the random sample of size 16 from a normal population with mean of sample. So mean of the sample is here 53. So that means x bar equal to 53. And the sum of squares of deviations from means. So sum of squares of deviation from the means. Means here we have only one x is there, no? So that's why x bar, sum of squares of deviations from the means. So that is equal to 150. So summation xi minus x bar whole square equal to 150. Can the sample is recorded as taken from the population with mean. So what is the population mean? Population mean is denoted with 56. So at level of significance alpha, alpha is here 5%. So here they have given that n equal to 16. This is small sample and x bar is 53 and alpha is 5%, that is nothing but 0.05, mu equal to 56. And also they have given that one clue, that is a summation, that is sum of squares of deviations from the mean is 150. So sum of squares of deviations from the means is 150. Okay, so but here we don't know. So we have formula for that is t distributions for single mean is x bar minus mu by s by root n. So but here they have not given s value. So for that we have formula, right? So that is s square equal to 1 by n minus 1 summation xi minus x bar whole square. So that is equal to 1 by n. N value is 16. 16 minus 1 into, so this is summation xi minus x bar whole square value is 150. So this is 150 by 15. So that is 10. Okay. So s square equal to here 10. So what about s? S equal to 3.16 and the root of 10, that is 3.16. Okay. So s square formula is this one. After that substitute the values here, we will get s equal to 3.16. So first one is, so for if we want to solve this problem, then we have to follow the procedure. So what is the procedure here? Here we have procedure of 5 steps. So first one is null hypothesis. Here we need to set up the null hypothesis. So what is our question here? The sample is same question. The sample is came from the population with mean 56. So here I am taking the sample is came from the same population of mean 56. Okay, same statement I am taking here. And alternative hypothesis. Alternative hypothesis is denoted with H1. So it is opposite to the null hypothesis. That's why this is mu not equal to. Opposite to the null hypothesis means if mu equal to 56, then we can take mu not equal to 56. Next, coming to the level of significance. So level of significance alpha equal to 0.05. So here we need to find t alpha by 2 at mu equal to n minus 1 degrees of freedom. So t 0.05 divided by 2 at mu equal to n minus 1 degrees of freedom. Okay, so t 0.025 at mu equal to 16 minus degrees of 1 degrees of freedom. So that is already I have shown now in the table. So like that we have to follow. So these are all alpha values. So here we have 0.05, 0.25 in the table. So in that these are all new values. Okay, so new value is here 15. Okay, so new minus 1. So that is 15, right? So 16 minus 1, that is 15. At 15 we have to take this one. Okay, so we will take this value. So that value is 2.131. So this value is 2.131. Okay, so t alpha here, t alpha by 2 value is 2.131. So next step is, our fourth step is t equal to x bar minus mu by s by root n. So here x bar equal to 53 and mu equal to 56. S equal to, already we have calculated, that is 3.16 divided by, and the root of n value is here 16. Okay, so substitute all these values in the formula, we will get t equal to 3.79. So if we have t value, then we have to convert into positive, but here this is positive value only. So what about the mod t? Mod t is 3.79. So here mod t is 3.79, t alpha by 2 is 2.131. So is 3.79 is greater than 2.131 or 3.79 is less than 2.131? Yes, 3.79 is greater than 2.131. So that's why mod t is greater than mod t is greater than t alpha by 2. So that means the calculated value is greater than tabulated value. So that's why we reject the null hypothesis. Okay, so what is the meaning of that when we reject the null hypothesis means here we reject our statement what we have taken in the null hypothesis. In the null hypothesis we have taken that the sample is came from the same population with mean 56. So that is a wrong statement. Okay, so like that we have to follow the problems and we have to follow the procedure. So here we have exercise problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.